Hello. We did ADM2 less than 15a, where we proved an informal proof of the Pythagorean theorem. Kind of gave you an intuitive notion about why it might be true and how you might prove it in class if you ever had to show this on a test. But today, the second half of that is going to be actually utilizing the Pythagorean theorem and understanding just some quick tests of how to, or some quick practice problems that will help you on the homework. So let's just do those. You're going to have to do, I think, 10 or something on the homework. Maybe hopefully your teacher doesn't make you do all 10 because it's the same thing over and over. But you should at least know how to do it. So let's do a few of those. Oh, ADM2 less than 15. Application of the Pythagorean theorem. All right, let's go. Okay, bam, okay, let's go. Okay, so let's just remind ourselves where we came from. So we had a problem. So this is where I showed you this a little bit yesterday. And, you know, basically the Pythagorean theorem that says that in a right triangle, the sum of the squares of the legs, which is, you know, these are your two legs, the two shorter sides, the sum of the squares, so a squared plus b squared, the length of a squared plus the length of b squared equals c squared, okay? The square of the hypotenuse. And so we did this example with 3, 4, and 5. So 3 squared plus 4 squared is 9 plus 16 is 25. So the square root of 25 is 5. So if one side is 3, one side is 4, the other side must be 5. Okay, good. So let's do a few more of these for practice. And I encourage you to, again, to do these on your own. Do these guys on your own. And then, so this is homework help. Let's just label this. Homework help. This should be a pretty quick lesson. Try these 3 and we'll walk through them kind of slowly. We'll do them in light blue. Okay, so pause and try. So I'm going to let you try all of them. And if you want to do one at a time, I'm not going to tell you pause and try after we do all 3, but we're going to just do each one of them. You know what? I'm going to change this one here. We're going to change this one to 6 and 8. Okay, so I assume you've paused and tried these. Now let's do these. So we got to first identify A and B. So this is our, remember, here's our rule. Now A and B are the two sides that are next to the right angle. Those are our legs, right? These are our two legs. And you know, the question is does it matter which one's A and which one's B? The answer is no. A and B can be either one. I could have just as easily called, you know, I could have just as easily said, well, that's not A and that's not B, but this is B and this is A. But C is always opposite the right angle. So let's write our formula down. A squared plus B squared equals C squared. Well, we know what A and B are, right? B is 5 and A is 12. So A is 12 squared plus B squared, which is 5 squared. So that equals C squared. Well, we got to do the math here and go 144 plus 25 equals C squared. So 169 equals C squared. And for those of you that know your tables, 13 squared is 169. Or you could have used a calculator and done a square root on this guy. And so we could have said, well, the square root of both sides, square root of 169 is 13, and that's C. So in other words, what times what is 169? 13 times 13 is 169. So here we're going to do the same thing. We identify our two legs. This is A and B. Yes, I could have said this is B and this is A. It doesn't matter. And so you get 6 squared plus 8 squared, and this is our C, equals C squared. There you go, 13. So we get 36 plus 64 equals c squared, or 100 equals c squared. Well, what times what is 100? Well, that's 10. So c equals 10. Or another way of saying it is the square root of 100 equals 10. What times what equals 100? Well, that's 10. So x equals 10. 10. Now, so far, each one of these, these have both been whole numbers. In this case, the answer is not a whole number. It is actually an irrational number. So let's look at how this happens. Well, this is our A and our B, and this is our C. So we know that 7 squared plus 2 squared equals c squared. Well, that's 49 plus 4 equals c squared. So 53 equals c squared. Well, there's no number that multiplied by itself is 53, or at least no whole number. So the way that we write our answer is we just say, well, c is equal to the square root of 53. And that means, this means the square root of x means what number times itself equals x. So the square root of 49, the square root of 9 is that what number times itself equals x. So the square root of 9 is 3, because 3 times 3 equals 9. So a square root of 53 just simply is a symbolic way of saying the number that multiplied by itself equals 53. And because there's no whole number that we know that equals 53, we just leave it as the square root of 53. And you're going to have a number of problems on the homework that look like that. If the number, if you know the square root, if you know what number times what number equals 100, or what number times what number equals 169, then you have to give me that number. But otherwise, if the number is not a perfect square number, then you have to leave it in this symbolic notation. And we'll happy cat all three of these problems. And we're going to now just return right back to our Google Hangout, and we're going to sign off, because this is just the second half of lesson 15. It's a little bit quick. Let me know if you need more sample problems, but they're all the same, at least in lesson 15. Lesson 16 is going to give you problems where you sometimes have the hypotenuse and only one leg, and we'll go through a few of those examples. And that will actually finish off 8M2. You've learned a lot. You've learned about congruence. You've learned about translations, rotations, reflection. You've learned about rules that apply to triangles, rules that apply to parallel lines cut with transversals, exterior angles, interior angles, alternate interior angles, corresponding angles. You've learned the Pythagorean theorem. You've learned the proof of the Pythagorean theorem, application of the Pythagorean theorem. This has been a ton. You've learned a lot in these 16 lessons. You should be very proud of yourself. So I'm gonna clap for you because you have learned a ton. Again, one more lesson and then we're done. We're gonna cut over to 8M3 and start learning some new math. I think you might have a test in there somewhere from your teacher. Let me know if you need any help on that. If you need any help on certain kinds of problems, certain lectures, leave me a note online. I'll put together more videos for you. But you gotta tell me where it is that you need that help. All right, sayonara, till tomorrow.